Dr. Mitchell again. This time we're going to be talking about mathematical expressions, focusing specifically first on how algorithms are constructed and what they are before we actually start getting into actually doing math in our programs. So what are we learning today? We're going to be learning how to express an algorithm that uses sequencing. We'll be focusing on deciding how algorithms or looking at how algorithms are represented, as well as the core components that make up an algorithm. So an algorithm itself is defined as a finite set of instructions that accomplish a specific task. We do algorithms every day in our daily lives. So you can kind of think of an algorithm like a recipe. When I go to bake cookies, I'm following very specific steps in order to, bake cookies and wind up with what the result that I'm expecting. If I am getting dressed in the morning, I follow a very specific algorithm in order to, make sure I put on my pants and then put on my shirt. Those steps or instructions help achieve the task that I'm trying to accomplish. Even when we're washing dishes, etc. We have algorithms all around us, and they're a core concept in computer science. So algorithms are made up of three primary components. The first component that we'll be looking at is sequencing. Sequencing just simply states that we're going to do these things in the order that they are given and specified. So when I have an algorithm and I have the first thing that I'm going to do, and then the second thing I'm going to do, and then the third thing I'm going to do, and they happen in that order. I don't go from my first step to my third step and then, back to my second step. I'm going to do them in those that particular order. When I'm dealing with selection, in my algorithms. Selection helps me to choose two different outcomes based off of a decision or a condition that I want to make or need to make. So, maybe I might do this first step, and then, depending on if it is raining outside, I'm going to take an umbrella. And if it's not, I'm going to leave the umbrella at home. So those selection components are key to algorithms. And then with iteration, sometimes in our programs and even in daily tasks, we might need to repeat something as long as something is true, or stop once that condition is done. So I might have my first step to do and then my second step, and then I check to see like, okay, am I done? Think like whenever you do your homework. First you do, problem number one. You have 10 problems on your paper and you do problem number one. And your condition is, have I completed all 10 problems, right? And then you go back and you do the next problem and then the next problem. So that would be a form of iteration, which is also referred to as repetition. So let's look at some examples of how we represent algorithms and how we write them. One common way of writing algorithms is using a flowchart. In this flowchart or algorithm, I am trying to count the number of even numbers that are in a list. So I start off by setting count to 0. I get the next number from the user. I check if it's even or odd. And then I check to see whether or not there's more numbers in the list before I finally display that final count at the end. So when I'm looking for sequencing, of course, I'm focusing on the arrows, right? The arrows tell me which way to go. So that is my sequencing in my algorithm, that I'm going to do this, and then I'm going to do this, and then I'm going to do this. I have selection in this algorithm by that decision that I'm making. Is the number even? If it's yes, then I'm doing this thing. If it's no, I'm doing another thing. So I have two different outcomes depending on the answer to that question. And I have iteration because I'm checking to see if I need to repeat a step based off of whether or not this condition is true. If I do have more numbers, I'm going to get the next number from the user. And if I don't, then I'm done, and I'm not going to keep repeating this algorithm. I can also represent algorithms in pseudocode. Pseudocode is kind of fake code, right? So it's kind of like a blend of, human language and it's a little bit of coding format. So that way we can represent our algorithms as specific as possible. So in this case, this algorithm is meant to find the largest number in a list of positive numbers. So you see that I'm going to set the largest number to 0, then I'm going to get the next number in the list. I'm going to see if that number is larger than what I currently have as my largest number. And if it is, then I'm going to set largest number to that number. If there's more numbers in the list, I go back, and after that it ends up being false or not true, then I'm going to display whatever that final result is for largest number. So I have sequencing because I have each of these in very specific steps. I'm going to do this, then I'm going to do this, then I'm going to do this. I have selection on step 3 because depending on that outcome, if the number is larger than my largest number, then I'm going to set, my largest number to that. And I have iteration or repetition because if I still have more numbers, I'm going to repeat some steps until I finally have no more numbers left. So let's practice this on your own. Take a moment to pause the video and identify where you see sequencing, where you see selection, and where you see iteration or repetition in this algorithm. So we have sequencing, again, indicated by our arrows. The arrows tell us which way I'm going to go, which thing I'm going to do next. I have selection when I'm asking the question, is the number greater than 0? Based off of the outcome of that question, I'm either going to add the number to the sum, or I'm going to just move on and check and see if I have more numbers left to look at, which is then also my example of iteration where I am checking, do I have more numbers? If I do have more numbers in the list, then I go back to the beginning and I repeat those steps. And if I don't, then I'm just done with that algorithm and I'm going to display the result of conducting this algorithm. Okay, let's look at an example that's written in pseudocode. Pause the video and take a moment to identify where you see sequencing, selection, and iteration in this algorithm. So again, our sequencing is indicated with our step numbers. I'm going to do this step and then this step, step 3, step 4, etc. I'm going to do those in that specific order. I have selection on step 3, where I'm checking if the number is item, then I will display that I found the item. And then I have repetition. If I still have more numbers in the list, I'm going to go back to step 2 and do those steps again. I'll do step 2 again, and then I'll do step 3, and then step 4. And if there's more numbers, I go back to step 2 again. And I keep doing that until there's no more numbers left. And then finally, I'll wind up on step 5. So what do we take away? Just to recap, we can express algorithms with sequencing. Our algorithms are meant to be very finite set of instructions to accomplish a task. And we can represent algorithms not just in programming languages, but we can do this in flowcharts and pseudocode. And our algorithms typically are going to consist of sequencing, selection, and iteration. In the next video where we look more at algorithms.